Hello class, this is Ms. Martins and we are in Unit 8 Energy. Today's objective is students will be able to explain the difference between kinetic energy and potential energy, and students will be able to describe how KE and PE are represented on a heating curve. So KE and PE are just acronyms for kinetic energy and potential energy. Before we get into this, I would like you guys to think now. When are you most likely to sweat? Is it A, when you're running around, or B, when you're sitting still? If you answered A, you are correct, running around. And you already have an understanding of how movement and temperature are related. So kinetic energy is going to be the energy of moving particles. If you ever think of kinetic energy, think about moving particles. The faster the movement equals the faster or the higher kinetic energy there will be. With that being said, which phase would you expect to have a higher kinetic energy? Think about the different phases: solids, liquids, and gas. If you answered C, gas, you are correct. Gas particles move the most. Going back to our particle diagrams of solids, liquids, and gas, our three phases, you can remember that solids vibrate, liquids roll around and touch, but gases move everywhere. They are the particles that are the farthest apart and constantly moving. So back to this question. If heat energy is added at a constant rate, why does temperature only increase at certain intervals? So we're looking at our heating curve again. And basically, the heating curve is telling us what is happening to a substance as heat is being added to it. Our substance is starting off in the solid phase, and then from B to C, that's the heat of fusion. C to D will be our liquid phase. D to E is our heat of vaporization, and E to F will be our substance in the gas phase. So as heat energy is being added, why isn't temperature increasing throughout the graph? Why is it only increasing from A to B, C to D, and E to F? So our answer lies within potential energy and kinetic energy. Potential energy is occurring during a phase change, whereas kinetic energy is occurring during a temperature change. Kinetic energy is going to increase when temperature increases, and it's going to decrease when temperature decreases. Kinetic energy and temperature have a direct relationship. When there is no change in kinetic energy, it means that there's going to be no change in temperature. So going back to our heating curve, during melting point and boiling point, our temperature is going to be remaining the same. So during the heat of fusion and heat of vaporization points on our graph, the temperature remains the same. Hence, during melting point and boiling point, kinetic energy also remains the same. So the purpose of this lesson is just to get you guys to understand what essentially is kinetic energy and potential energy, and what does it have to do with this heating curve graph. So this is the main point that you need to take away. During the melting point and the boiling point, if the temperature is going to be remaining the same, so the kinetic energy also remains the same. During which interval does the kinetic energy increase? So from A to B, we can see that there's a temperature change. From B to C, we see that there's no temperature change. And from D to E, there's also no temperature change. We have an understanding that kinetic energy and temperature change have a direct relationship. So if the kinetic energy is increasing, then the temperature must be increasing as well. And the only interval within our answer choices that display this would be answer choice A. Our next question: during which interval does kinetic energy remain the same? Is it A to B, C to D, E to F, or D to E? So basically, during A to B, C to D, and E to F, our temperature is changing. Hence, our kinetic energy is also changing. The only interval within our answer choice that shows us kinetic energy remaining the same is when the temperature is also not changing, which is going to be D to E in our answer choice. And also C to D, but that's not in the choices. So potential energy. Potential energy is energy that is stored. It is found in chemical bonds, food, fuels, wood, found in intermolecular forces between atoms, and bonds holding compounds together. Which phase would you expect to have a higher potential energy? So it's going to be the opposite of kinetic energy, and solids have the strongest intermolecular forces. They're the closest together. They're not moving as much. They're vibrating around each other. So our answer is going to be solids. Remember, solids vibrates, liquids roll around and touch, and gases move everywhere. Solids have the highest potential energy, whereas gases have the higher kinetic energy. So if we're looking at our heating curve once again, during melting and boiling point, PE is going to be increasing. Heat is being added, but temperature is not changing, so our potential energy is what is going up. And during condensation and freezing, so we're going backwards on our graph. If we're looking from left to right, heat is being added. But if we're going from right to left for this table, the heat is being released, therefore it's cooling. Condensation and freezing represents the cooling curve, right? So PE is going to be decreasing. Heat is leaving, cooling, and temperature isn't changing, so PE is going to be decreasing. During which interval does the PE actually increase? Is it A to B, B to C, C to D, or E to F? So we know that our PE, the definition for potential energy, is going to be stored energy, and stored energy is going to increase when the temperature is not changing. So the interval that does not demonstrate a temperature change is going to be BC, which is our answer. So that's it for today's lesson. I have an exit ticket up for you guys on Google Classroom. Complete the form and make sure you stay safe. If you have any questions, I will be going live, or you can request for me to go live on a one-on-one. I hope you guys enjoyed this lesson. Make sure you stay safe and enjoy your day.